Hello everyone. Today I'm going to begin Unit 7, which is called Stoichiometry. Now stoichiometry is kind of an intimidating word. Stoichion means element and metron means to measure. Just to give you a definition of stoichiometry from the dictionary, it is the relationship between the relative amounts of substances taking part in a reaction or forming a compound, typically a ratio of whole integers. So again, that may not make a ton of sense, so to simplify it even further, I'm going to show you a simple recipe. So this is a recipe for sugar cookies, and if you combine all these ingredients and bake them, you should produce 48 cookies. Well, that's a lot of cookies. So let's say you don't want 48 cookies. Let's say instead of 48, you only want to make a dozen. You only want to make 12. So if I only want to make 12 cookies, I would be curious about how much of the other ingredients I would need. So let's say that our problem is to produce 12 cookies. How much flour do I need? So now we're going to set this up using dimensional analysis. Start with what you know. You know that you have 12 cookies, or that you want to produce 12 cookies. So I'm going to move cookies to the bottom. And I'm going to put flour, what I don't know, on top. Well, my ratio that I need to use here is for every 2 3/4, which is 0.75 cups of flour, I produce 48 cookies. So now I just set this up using dimensional analysis. 12 times 2.75 divided by 48. And I get 0.6875 cups of flour. Now, you might have already been able to tell that if we want to produce a dozen cookies instead of 48, that's the same thing as dividing 48 by 4. So we could just take the amount of flour and divide it by 4. 2.75 divided by 4 gives us 0.6875. And that would be what you would do with all of the ingredients. That's a very simple problem. Those of you that like to cook or bake cookies and cakes, you know how to double a recipe or how to half a recipe, or in this case, to reduce everything to only a quarter of the original recipe. Well, I wanted to show you this simple example because this is exactly what we're going to be doing with chemistry. You're going to be given an amount. It might be the product, it might be one of the reactants, and you're going to have to change that number to something else. You might be decreasing it like we did here, or you might be increasing it to a bigger number. But the way you do that is you have to use a ratio. And just like this recipe, your balanced equation is going to serve as your ratio. So we're going to go back to the PowerPoint now. I'll go through a few slides with you and then we'll work some problems together. So in this unit, today in particular, we're going to be learning how to convert between grams and moles of two different formulas. So far, you have been converting between grams and moles of the same element or compound. So the thing that makes mole ratios, what we have been doing, different in stoichiometry is that it's two different formulas. And that's all we'll cover today. Later in this unit, we will cover how to identify limiting reactants. So that's the reactant that runs out first when you have a reaction. The reactants that are in excess, meaning there's still some left over after the reaction stops, those are called your excess reactants. And then we're going to learn how to calculate how much of that excess reactant is left over or is unused at the end of the reaction. You'll also learn how to calculate the theoretical yield In other words, how much product should you be producing by these reactions? And then you'll compare your actual yield. So if you were to conduct a lab and you were trying to figure out how much product you produced, you will compare that to the amount of product you should have produced. That's the theoretical yield. And you'll use that information to calculate the percent yield. Now we'll get into all of that later, probably next week, but for the sake of today, we're going to focus on this first objective. So how do you convert between two formulas? So I already mentioned this, but you need to begin with a balanced equation. The purpose of your equation is to show you what your reactants are, what your products are, and how many reactants you need to produce a certain number of products. That's what the coefficients in your balanced equation are used for, to tell you the relative amounts of what you're using and what you're producing. So for example, in this reaction, if I were to read this like a sentence, this reads 1 mole of nitrogen gas added to 3 moles of hydrogen gas produces 2 moles of ammonia, NH3. Now you might be wondering, where did I get 1 from? Where did I get the word mole? But that's what these coefficients mean. They are telling you the relative amounts or the number of moles of each compound that you have. So if there's not a coefficient, in the case of nitrogen, there's not a coefficient, we assume that's 1 mole of nitrogen. Now these coefficients are going to be used to write a ratio, a mole ratio between the different formulas. So if we were comparing nitrogen to hydrogen, it would be 1/3. 1 is the imaginary coefficient in front of nitrogen. 3 is the it's not imaginary. 3 is the coefficient in front of hydrogen. If you were comparing hydrogen to ammonia, the ratio would be 3:2. 3 is in front of hydrogen, 2 is in front of ammonia. And then if you were comparing the ratio of ammonia to nitrogen, it would be 2:1. Now these are going to be what we use to convert. So in the same way earlier, when I was converting cookies, when I was trying to figure out the new amount of flour to use to produce 12 cookies, I had to use a ratio. I used the amount of flour to the 48 cookies produced. So that's what this is going to serve as. Your mole ratio will be your conversion factor for these problems. All right, so here are your steps. You must write a balanced equation. And rather than give you a list of steps, we're just going to work this first problem together. So let's look down at my document camera. And I have copied this problem down for you. It says calculate the number of grams of ammonia produced when 5.4 grams of hydrogen reacts with nitrogen. Well, first we need to begin with a balanced equation. Now this happens to be the same equation we just looked at. Nitrogen plus hydrogen yields ammonia. And to balance it, we put a 2 in front of NH3, and we put a 3 in front of H2. Now, something you need to understand is that we cannot convert one formula to another formula if they are in grams. The only way we can go from one formula to another formula is if we first convert these numbers into moles. So that's what I'm going to do to begin with. I'm starting with what I know. I have 5.4 grams of hydrogen, and I want to convert that into moles. Now you might remember that hydrogen's molar mass is 1.01. Since it's H2, it's going to be 2.02. And it's going to be really important in this unit that you label carefully, or you can get really confused. So now, if I were to go ahead and solve, I would have moles of hydrogen, but I'm not ready to do that. Now I want to convert moles of hydrogen into moles of ammonia. So So I'm going to move moles of hydrogen to the bottom, and I'm going to put moles of ammonia on top. Now what I'll be filling in here is a mole ratio. And remember where I'm getting that mole ratio from? I'm getting it from the coefficients. So the coefficient in front of ammonia is 2, and the coefficient in front of hydrogen is 3. And guys, I just noticed that my hands are covered in paint, so if you're wondering what all that stuff is on my hand, I have been painting pretty much my entire spring break, so I apologize for that. Okay, now we're not quite done, because remember the problem is asking you to calculate the number of grams of ammonia. So we've got one more step, and that is to move moles of ammonia to the bottom and to put grams of ammonia on top. So this is where we'll put the molar mass of ammonia. So remember, hydrogen's mass is 1.01 times 3. And then we're going to add that to nitrogen's molar mass, which is 14.01. So let's see what we get. All right, we get 17.04. That's going to go here. So once again, just to kind of bring it back to what we've done, when we were looking at this recipe here, we just went straight from cookies to flour by using the ratio of flour to 48 cookies. We can't do a simple ratio with this problem because this is in grams. So you first have to convert this into moles. You know how to do that. You're just dividing by the molar mass. Now you set up your ratio. What you're trying to find over what you already know, 2 to 3. And then you're going to multiply this by the molar mass of ammonia because that's what they asked for. They didn't ask for moles of ammonia, they asked for grams of ammonia. So now we're ready to solve the problem. So I'm going to type in 5.4 divided by 2.02 times 2 divided by 3 times 17.04, and I get 30.4 grams of ammonia. And notice with significant figures, I'm not going to be counting off for that, so you don't have to worry as far as your grade goes, but it's always a good rule of thumb to round your answers to the correct number of sig figs. And in order to determine that, just look at the number given to you in the problem. This has 3 sig figs, so my answer has 3 sig figs.